Have you guys ever wondered how chemists differentiate between various compounds like maybe aldehydes and ketones or alcohols and amines? Is it by their color change, pH change, temperature, or maybe some other factors? Well, let's see those tests to distinguish between various organic compounds. To begin with, we'll be looking into the test to distinguish ketones and aldehydes. First one will be Fleming's test. Fleming's reagent consists of Fleming solution A, which is aqueous copper sulfate, and Fleming solution B, Rochelle salt, which is alkaline sodium potassium tartrate. This is used for the distinguishing of aldehydes, and when an aldehyde is warmed with both these solutions, a reddish brown precipitate of cuprous oxide is formed. And a point to be noted is that this test is not applicable in the case of aromatic aldehydes due to resonance stabilization of the benzene ring. The test tube contains aldehydes and Fleming solution A is added, then Rochelle salt, and warmed in a water bath for 5 minutes, and this is the reddish brown precipitate obtained. Next is tolerance test. Tolerance test is also used for the distinguishing of aldehydes, and tolerance reagent is ammoniacal silver nitrate solution. And on warming an aldehyde with this tolerance reagent, a bright silver mirror is obtained in the test tube, which is actually due to the formation of silver metal. And this reaction occurs only in the presence of an alkali medium. This test tube contains benzaldehyde, and tolerance reagent is added and warmed in a water bath, and this is the silver mirror obtained. Next is iodoform test. Iodoform test is used for the distinguishing of a ketone with a methyl group attached to it, or a secondary alcohol with a methyl group attached in its alpha position, or maybe an aldehyde with a CH3 group attached to it, which is nothing but acetaldehyde. And when these compounds react with sodium hypoiodide, which is iodine plus sodium hydroxide, it results in the formation of triiodomethane, which is actually a pale yellow precipitate. Next is those tests to distinguish between various amines, and first is isocyanate test. Isocyanate test is also known as carbyl amine reaction, and it is used for distinguishing between primary amines, which is aliphatic and aromatic. So in this reaction, primary amines are treated with ethanolic potassium hydroxide and chloroform, which is CHCl3, and it results in the production of RNC, which is isocyanates or carbyl amines, and they are actually foul smelling substances. Next is Hinsberg's test. Hinsberg's reagent is benzene sulfonyl chloride, and this test is used for distinguishing primary, secondary and tertiary amines. So when a primary amine reacts with benzene sulfonyl chloride, it results in the formation of a sulfonamide product, which is actually soluble in alkali, because this nitrogen has a highly acidic hydrogen atom attached to it due to the presence of the electron withdrawing sulfonide group. Whereas when a secondary amine react with Hinsberg reagent, it also results in the formation of a sulfonamide product, which is not soluble in alkali because it does not have a highly acidic hydrogen atom attached to the nitrogen. And no such reaction occurs between a tertiary amine and the benzene sulfonyl chloride. Next is reactions with nitrous acid. This is used for identifying aliphatic amines and aromatic amines. When a primary aliphatic amine reacts with nitrous acid in the presence of sodium nitrate and hydrochloric acid, a diazonium chloride salt is formed, which is actually unstable. So it undergoes decomposition in the presence of water to form alcohol, hydrochloric acid, and mainly nitrogen gas, which is seen as bubbles. Whereas when an aromatic amine reacts with nitrous acid, under the condition 273 to 278 Kelvin, it results in the formation of benzene diazonium chloride, which is stable due to the resonance stabilization of benzene ring. Next is azodite test. Azodite test is also known as coupling reaction, and it is used for confirming the presence of primary aromatic amine. So as we have seen in the previous slide, aromatic amines react with sodium nitrate, hydrochloric acid to form diazonium chloride salts. So when these diazo compounds react with aniline, it forms para-aminoazobenzene, which is actually a yellow dye. It also reacts with phenols like beta-naphthol to form para-hydroxyazobenzene, which is orange dye. This test tube contains aniline and hydrochloric acid is added to it, then called aqueous sodium nitrate, and this mixture is added to phenol, which gives yellow dye. Next are those tests to distinguish between various alcohols, and first one is neutral ferric chloride test. This is used for the distinguishing phenol from other various alcohols, and so a phenol group reacts with the ferric ion present in ferric chloride to form a violet colored complex, which is hexaphenoxide of ferrite. This test tube contains phenol and neutral ferric chloride is added, and the test tube is then shaked gently and a violet colored complex is formed. Next is Lucas test. Lucas test is used for distinguishing primary, secondary and tertiary alcohols. Lucas reagent consists of anhydrous zinc chloride and concentrated hydrochloric acid. So when Lucas reagent reacts with a primary alcohol, a normal solution is formed which does not appear turbid and at room temperature. But when it is heated for like 30 to 45 minutes, a turbid solution appears. But when a secondary alcohol reacts with Lucas reagent, a turbid solution appears within like 3 to 5 minutes. And for tertiary alcohols, turbidity is seen immediately at room temperature as soon as the reagent is added. So in this picture you can see 1-butanol, which is a primary alcohol, reacts with Lucas reagent and gives no turbidity. 2-butanol, which is a secondary alcohol, gives turbidity within 3 to 5 minutes, and 2-methyl-2-propanol, which is a tertiary alcohol, gives turbidity immediately. So these are the name of test, reagents, results and distinguishes, what it distinguishes in a nutshell. So let me ask you a quick question. In which test is a reddish brown precipitate is obtained? Can someone? Yeah, can someone tell me what the precipitate is? I mean the name of the precipitate. Yeah, cuprous oxide. So the question was, in which test is a reddish brown precipitate obtained as a result, and what's the name of the precipitate? It is Felling's test, and the precipitate is cuprous oxide. So now, as we have already learned all these tests, just think about how this can help you in your field of study or in lab setting. These aren't just for your chemistry exams, but these are used in pharmaceuticals to test the purity of different substances, or in food industries to detect certain compounds. For instance, a simple test for aldehyde can be used to check food quality control. By observing how different substances react in different tests, we can gain insight into their structure and their characteristic, making these crucial in both practical as well as academic applications. Thank you for your time and patience. I appreciate your attention, and I hope this session was helpful. If you have any doubts or need clarifications, please feel free to reach out. Thank you.